Hey everybody, in this video we'll talk about expanding a logarithmic expression, problem type 1. Before we go ahead and get started on this one, let's talk about a few more properties of logarithmic expressions. So in a previous video I talked about the properties 1 through 4. Let's talk about the properties 5, 6, and 7 and how we might be able to apply them. So if we're given log of any base with a product inside of our log, okay, then we can split that product as a sum of two separate logs. So this would be log base b of x plus log base b of y. Okay. Now also we can do similar with a quotient inside of a log, and we can split it as a difference of logarithmic function expressions or pieces. And then the next one is if we have something raised to the a power inside of our log function or a log expression, we can pull out a p or pull out the exponent, the power of x, and multiply that by the log base b of x. So let's look at some fill-in-the-blank type answers for this problem. So this kind of continues with basic properties of logarithms, but here we have a sum of two different logs that have the same bases. Now we have to make sure that we have the same bases before we can use this property, but the product property that we talked about says that if we have a product of inside of our log function, we can split it into a sum. So here's an example of what that would look like. We can simplify it more. So it would be log base 9 of 56. So we would want to fill in that blank with 56. Now for this one, we can use the quotient property of logs, where if we have a quotient inside of our log function, we can split it into two separate logs with the same bases, and we will have the log base 4 in this case of our numerator minus log base 4 of our denominator. And then for this next one, negative 2 log base 6 of 2, what is that going to equal? Well, remember the exponential rule of log says that if we have log base b of anything raised to a power, or I believe it was written like x raised to the p, that's going to equal p times log base b of x. So we can see we can pull this negative 2. Now we have to take this whole negative 2 and it becomes our exponent. So this is 2 to the negative 2 power, and what does that equal? Well, 2 to the negative 2 power equals 1/4. So this blank would be 1/4. Okay, so there's a little more on basic properties, but let's go ahead and use that to expand a logarithm. So for this problem type 1, what can we do? Well, I see inside of here, the first thing I see is I have a product. Now I also have an exponent, but I want to take care of the product first because the exponent isn't attached to the x, it's only attached to the y. So the property of logs that has a product says that this is equal to log of y cubed plus log of x. Now why don't I have a base? Because remember, if it's a log and it doesn't have a base, we just assume it's base 10. Now I can take this cubed and use the exponential rule to bring it in front, 3 times the log of y plus the log of x. And that is fully expanded using my properties of logs.